Hello, this is Math 6, Lesson 3-1, Topic 3, Lesson 1, Understanding and Representing Exponents. In this lesson, you'll be able to write and evaluate numbers with exponents. You'll also write expressions using whole number exponents to represent real-world and mathematical problems. You'll evaluate expressions with whole number exponents. Also, you'll be able to explain how to write and evaluate numbers with exponents. Let's look at solve and discuss a question. Fold a sheet of paper in half. Record the number of sections you see when it is unfolded. Continue folding the paper in half 4 more times. Record the number of sections each time. Describe any patterns you see. Okay? So if you fold a blank piece of paper in half, how many sections do you see when you unfold it? You have 2 sections when you fold it in half. And then you fold another half after that. Okay, fold it 2 times. And then you should have how many sections? 4 sections, 1, 2, 3, 4, because you're dividing everything by half 2 times, right? So if you fold once, you have 2 sections. Okay, and then you fold twice, you have 4 sections. If you fold another half, so let's fold it. I'm gonna fold this paper in half. Okay, and then fold it half again. And then I'm gonna fold it half again. So then how many sections do you think you'll see? Let's see. We're gonna unfold it. And we have how many sections? 1, 2, 3, 4, 5, 6, and 7, 8. 8 sections total. So if you fold the paper 1, 2, and 3 times in half, we have total of 8 sections, right? If you fold it in half once again, 4 times, what do you think you'll see? How many sections do you think you'll see? 1, 2, 3, and then 4. You're dividing all sections you have in half again. So you previously had 8 sections. If you divide all 8 sections in half, how many sections would you see? 16, right? Do you see the pattern? Yes, you're multiplying 2 each time, right? Wait, you're multiplying 2 each time, yes. So how would you describe the pattern? The number of sections, this part, doubles each time, right? Let's write that down. The number of sections doubles each time. Okay. Let's look at this question on the bottom. How many sections will there be after 6 folds? We know that pattern. How many sections will there be after 6 and 7 folds? Okay, you have 4 is 16. We can keep building our table. You multiply 2 to 16 to get the 5th fold, which is 32. What about 6? 64. What about 7? 128, and so on, right? So after 6 folds, we have 64 sections. And after 7 folds, we have 128 sections. Okay, that's a lot of sections. But Yes, without being able to fold it literally with your paper, if you figure out a pattern, you can figure out how many sections it will be after 6 and 7 and more folds. Let's look at the next page. In this lesson, continue thinking about how you can write and evaluate numbers with exponents. Example 1. Understand and represent exponents. The expression 2 times 2 times 2 represents the number of cells after 1 hour if there is 1 cell at the start. How can you write this expression using exponents? How many cells will there be after 1 hour? What is an exponent? Does anybody know exponents? Have you seen exponents before? You might have seen it. You probably might have not recognized it. Or if you already studied, then you should know what exponents are. They're the little powers, the tiny little numbers on top of the base number. Okay, so if you're multiplying the same number, the same number n times, like how many times you would like to, we want to compress that multiplication so that it's easy to see and easy to write. 2 times 2 times 2 is 2 multiplied 3 times, right? And if we have a lot of the same number multiplied together, maybe like 10 times, then it might be too much work to write all of them down. 2 times 2 times 2 times 2 times 2 times 2 and dot dot dot, right? And you lose track of how many numbers you wrote, right? So we're gonna make a notation for that. 2 times 2 times 2 will be written as 2 to the how many power? The third power, because it's multiplied 3 times. Notice it is not multiplied by 3. It's not 2 times 3. 2 times 3 is a totally different number, 6. 2 times 2 times 2 is 2 multiplied 3 times, okay? That little number represents how many times you're multiplying the same number, which is called the base, okay? So this is called, the 2 is called the base. The number that's actually being multiplied is called the base. The exponent is the little number on top. The exponent tells how many times the base is used as a factor. Okay, so you're not actually multiplying the exponent directly. It tells you how many times. Okay, do not use 3 in your multiplication. Just count the number of times you're multiplying. Okay, this is also called the power. Okay, you have 2 to the power of 3. Or you can also read that as 2/3. Okay, you can use repeated multiplication to evaluate, which means find the value of a power. So 2/3, if you just look at the 2/3 and you want to know what 2/3 is equal to, you multiply 2 3 times. 2 times 2 times 2 is 8. 2 times 2 is 4. 4 times 2 is 8. So 2/3 is equivalent to 8. And you can say there will be 8 cells after 1 hour because 2/3 represents the number of cells after 1 hour. Okay. Let's look at try question number 1. There are 2 times 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 2 bacteria cells after 3 hours. Ooh, how many times are we multiplying 2? How many 2's do you see? Write the repeated multiplication as a power and then evaluate. This is 2 times 1. And then you have 2 to the power of 2. You're multiplying 2 twice. 3, 4, 5, 6, 7, 8, 9. So this is 2 to the power of 9. And then evaluate means find the value, actual number for this power. So if you multiply this out 9 times, If you multiply 2 out 9 times, you get twice is 4, 8, 16, 32, 64, 128, 256, and then 512. Okay, so 2 to the 9th power is equal to 512. Why can you represent the number of cells after 2 hours as the power of 2 to the 6th? This is 3 hours, right? Why can you represent the number of cells after 2 hours as the power of 2 to the 6th? Think about your pattern. The base is 2 because each cell divides into 2 cells. So you're going to have double bacteria every time, right? So the numbers repeatedly multiplied by 2. The exponent is the number of times the cell divides. So each hour contains how many 20-minute period where the bacteria divides? 2, 4, 60. So 60 minutes would have 3 20 minutes, right? So there are 2 times 3, 6 periods in 2 hours. So the exponent is 6. So you divide, the bacteria divides 6 times. So let's record that. How many periods? Okay, does that make sense? The base is 2 because each cell divides into 2 cells, so you multiply by 2, right? And the exponent is the number of times the cell divides each out, and every 20 minutes the bacteria divides, right? So each hour has 3 20 minutes. So if you multiply that by 2 by 3, because that we're looking at 2 hours. So every hour it's 3, they divided 3 times. And if you have 2 hours, you divide 6 times. So there are 6 periods in 2 hours. So your exponent is 6. You're dividing 6 times, which means you're multiplying 2 6 times. Okay. Let's look at the next example. Example 2, evaluating exponents. Part A, how can you evaluate 2 to the 0th power? What is a number to the 0th power? What does that mean? If the base is 2 and the exponent is 0, what does it mean? You're multiplying 2 how many times? 0 times. Well, how can you figure that out? Is that 0 or 1? You can look at a table. You can make a table and look for a pattern. If you multiply 2 once, that's 2. If you multiply 2 times, that's 4. If you multiply 2 3 times, that's 8. And 4 times, that's 16. What about going backwards? If you multiply 1 less time, what happens to your number? What happens to your value? You're actually dividing it by 2 whenever you're decreasing the number of your power, right? Does that make sense? So what does 2 to the 0th power mean? You're dividing 0 times, which means from the first time you're multiplying, right? You're going to divide by 2 to go backwards into power. So 2 divided by 2 is 1. Any number to the 0th power is 1 because any number multiplied once is itself, and itself divided by itself is going backwards into power, which means the number divided by the number is always going to be 1. Any non-zero number raised to an exponent 0 has a value of 1. Remember that. Part B, how can you evaluate 1.2 to the 4th power? What if you have a decimal, not just a whole number for your base? Evaluate your base. You identify your base and the exponent first. What does it mean? Your base is 1.2. Your exponent is 4. What does it mean? You're multiplying your base by 4 times. 1.2 times 1.2 times 1.2 times 1.2. So you can literally multiply it by itself 4 times. So if you multiply once, it's just 1.2. Multiply twice, 1.44, 3 times 1.728, 4 times 2.0736. So 1.2 to the 4th power is 2.0736. Okay, decimal, it's totally fine on the base. Okay, decimals on the base, that's okay. Even the fraction, you multiply it how many times the power tells you to multiply by. Okay, do it one by one. Let's look at try it. Can you evaluate 1/3 to the power of 3? So now you have a fraction. What does that mean? 1/3 times 1/3 times 1/3. You're multiplying 1/3 3 times. So what is it? 1/3 times 1/3 is 1/9. 3 times 3, 1 times 1. 1/9 times 1/3. 1/27. So 1/3 to the 3rd power is 1/27. Okay. Look at example 3. Evaluate expressions with exponents. Julia calculated the FOIL as 1.9 times 10 to the 5th power units thick. Tom calculated the FOIL as 183,000 units thick. Which calculation represents the greater thickness for the FOIL? Let's figure out if the numbers are the same or about the same, which number is bigger. In order to do that, we need to evaluate this 1.9 times 10 to the 5th power. What is 10 to the 5th power? You multiply 10 5 times, and that will get you 100,000, right? 10 times 10 times 10 times 10 times 10 is 100,000. And so if you multiply 1.9, 100,000, you're gonna get, you move decimal place 1, 2, 3, 4, 5 units to the right. So how many zeros do you have? 4. And that's going to be 190,000. Is 190,000 bigger or 183,000 bigger? 190,000, right? So Julia's calculation represents the greater thickness for the FOIL is your final answer for this word problem. So remember to interpret what your number means and what was your question really. You need to answer your question. You can't just say a number, 190,000, done. Like, what does that mean? You need to say Julie's calculation represents the greater thickness. That is the answer for your question here. Okay. Try it. Raphael calculated the FOIL as 1.8 times 10 to the 4 units thick. Evaluate Raphael's expression. So if they do not have questions like this, if they say evaluate, that is a number answer. Okay, that is only when you write the answer as the final answer. So let's evaluate this number. What is the actual value of this? Right? 10 to the 4th power is multiplying 10 4 times. Okay? 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. You just add 0. So how many zeros do we have? 1, 2, 3, 4. Okay? 1.8 times 10,000 is 1.8, moving your decimal point 1, 2, 3, 4 times. By how many zeros you have, right? So you're right here. And that's equal to 18,000 units of thickness. Any question? Okay, let's summarize the lesson. We looked at understanding our representing expressions lesson. You can represent a repeated multiplication expression using an exponent. Remember that the base is the actual number that's being multiplied. Exponent is the small number on top of the base that tells you how many times you're multiplying. Base and exponent together, they're called power. Okay? You can evaluate a power using repeated multiplication and multiplying the base out. Okay, for example, 5 to the 4th power is 625. All right, that was lesson 1. You should know that the base is the number being multiplied, the exponent is the number of times that the base is a factor, and the power is a combination of the base and the exponent, which represents a number. And that wraps up our lesson. All right, I'll see you in the next lesson.